Gariahat. 2023 advanced question on circuits. This is, I will say, a magnificent fast question. Capacitor C is initially uncharged and the key K is open initially. In this condition, a current of 1 ampere flows through the 1 ohm resistance. This 1 ampere current flows in which direction is the question. Now see this. 15 volts, 5 volts. This is a dominating potential. The current from this battery would enter this side, and that means the current of 1 ampere flows through the resistance in this direction. Important thing to be noted right at the beginning. There should be no confusion on this. The key is closed at a certain instant of time, then which of the following options hold? Here we begin with the question. We simply go by applying an idea that, let's say, this battery throws a current of I, and then this current splits into 1 and I minus 1. Well, this current then splits into some parts. Now, this particular part of the circuit is before the key is open off the grid. This is not into the circuit, and therefore this part is not carrying any current. We simply have two loops to take care. One is this one and one is this one. We apply a KVL straightforward here, and the KVL goes like this, dear. In the upper loop, the plus 15 volts and then a current drop minus of IR, and then through this 1 ampere into 1 ohm is a minus 1 volts. Then from positive to negative terminal, a minus 5 volts. Drop of 5 volts from higher potential to the lower side completes the loop. That means 15 minus 5, 10 minus 1, 9 is equal to I into R. Let this be the equation. Now let's go to the second, this loop. In this, the 5 volts from lower to higher potential plus 5 volts, and you are flowing across against the current. So this is a 1 volt plus, so plus 1. And then this current flows, and then this current flows into this. This is I minus 1 current, because this part is off the grid, as I told you, and hence I have a drop across this resistance. Plus 3 times, no, it's a drop, minus 3 times. Minus 3 times I minus 1, and then the loop completes is equal to 0. 6 plus 3, 9. 9, 6 plus 3, 9, minus 3I, so equal to 3I. I is equal to 3 amperes. Using this over here, using these two, R is equal to 3 ohms. So I have some option here which is relevant. The value of the resistance R is 3 ohms. It's cool, correct. For T less than T naught, that means when the key has not been connected, the value of the current I1, which is I1, which current is I1? This current is I1. Oh, see this. And this I1 is therefore equal to the I minus 1 value. I is this. So therefore I1 is 2 amperes. So therefore the value of the current I1 is 2 amperes is a correct option. Now for time after T naught, that is when the key is closed at a time T naught. After this, what happens? Once this part of the circuit comes into picture, you have the capacitor plates which were initially uncharged gathering charges. It starts accumulating charges. Let's say at an instant of time, the amount of varying current that flows into this part of the circuit is I, and this plate carries, this plate carries a plus Q charge and this one carries a minus Q charge. This is when this key has been closed. So I will just close the key here, and here the circuit is complete. Now the situation is the capacitor is experiencing charging. So Q equal to Q naught 1 minus e to the power minus t by t naught is what applies to the plates of the capacitor. Before this, we need to go ahead a little into the data. How much is the time that has been given? The time that has been given is in the option 7.2 microseconds. So I will consider this as a 7.2 microseconds. How much is tau? Tau is equal to R into C. I will call this R naught. And what is R naught? The associated resistance. So R naught into this capacitance C, values are given. 3 into 2 micro. So I will say this is 6 microseconds. Now that means T by tau value is equal to 7.2 by 6 is equal to 1.2 as a ratio, which will come to the power of e to the power minus 1.2. Now Q naught, how much is Q naught? Q naught is the total amount of charge, maximum charge that these plates can acquire. But actually we do not need this equation that. Why I wrote this equation? You must be wondering so far. Here is the answer. How do you calculate I? This I will be equal to dq by dt, the rate of change of charge per unit time. So if I is equal to dq by dt, it's a time derivative of this, and q naught into derivative of this 1 goes minus remains e to the power minus t by tau remains derivative of minus t by tau. So derivative of t is 1, tau comes to the denominator. This is what the current value would be. Now how much is q naught? Here the value of Q naught would be equal to C into V, the capacitor plates and the potential across it. Now, what is the potential across the plates? Let's see. If current I is 3 amperes and resistance is 3 ohms, this is 3 ohms. This potential drop is 9. So 15 minus 9, this is a 3 ohm resistance. This is a 3 ohm resistance. So 9 volts drop across the resistance. So 15 minus 9 would produce a potential difference of 6 volts across these terminals. Also say this, 5 plus 1, 6 volts. Or you say this, I minus 1 is a 2, 3 into 2 is a 6 volts. So the amount of potential difference across the capacitor plates is 6. So I have this Q naught value as equal to 2 microfarads into 6, that is 12 microcoulombs. This is Q naught value. Now, if you put this into this calculation of I becomes equal to Q naught, which is 12 micro by tau. Tau is equal to 6 micro. So micros cancel. And what remains is e to the power minus t by tau, that is 1.2. Now you have the value as 2 into e power. 2 into e power minus 1.2 is the current value. When time is 7.2 microseconds after the key has been closed. Now e to the power minus 1 is 0.36. From this we can guess that approximately e to the power minus 1.2 would be approx 0.3, and therefore if that is 0.3, this is 2 into 0.3, which makes it 0.6 amperes. So is the option talking about this? Oh yes, and therefore this is correct option. Now next, for time tending to infinity, that is a long time, charge on the capacitor plates is 12 microcoulombs. That is what this thing says. So this is a correct option. Now you see, all the 4 options have been found correct. Though the discussion, the explanation took some time, I would suggest that you go speedily on such questions in the exam hall, and for that what you need is a very clear understanding of the theory. Stay subscribed and stay revised for more exciting questions coming along, and thank you for your patience. See you in the next question.